What statement most accurately describes discontinuities in the graph of f of x here? Well, let's start with this. When we talk about discontinuities, there's three types. You can have infinite, and that's when you divide by 0. You could have a jump, and that comes from piecewise when the two equations don't match up. Or you could have removable. And that's when you have a factor that looks like it's dividing, like here, where you divide by 0, but it actually cancels with the numerator. So those are the three types you can have. All right, so let's try this out. When I look at this problem, I see first it's piecewise, which means I might have a jump. The way you test for jump is you use these values. So the values where this might jump is at the value of 1. Now we can go to the graph and we'll check that at the end, but I want to show you algebraically first. I want to know what the numerator value is and the denominator. If they're different, it's a jump. So when I plug in 1 to the top here, I would have 2 times 1 squared plus 3 times 1 minus 2 all over 1 plus 2. Okay, when I add this up, 1 squared is 1. I'm following PEMDAS here, so I got to square this first. That's 1 times 2 is 2 plus 3. So I got 5 minus 2, which is 3, divided by 1 plus 2 is 3, which that equals 1. So the top value is 1. Now let's try the other end of f of x. When we plug in here, we'd have negative times 1 squared plus 2. Again, you got to follow PEMDAS. 1 squared is 1, make it negative. So negative 1 plus 2 equals 1. You see how they're the same value? Since they're the same, this is not a jump. Not a jump since both equations equal 1. And really, I shouldn't say equations, both pieces. Both pieces of the piecewise equal 1 when x equals 1. Okay, so it's not a jump. All we need to check now for is these two. Now, like I said, infinite and removable come from whenever you have an equation dividing by 0, which I do here. I'm going to have either infinite or removable, because when I can tell that when x is negative 2, I'll have negative 2 plus 2, I'd be dividing by 0. That's a problem. So all I got to really check is the numerator here, just to see if I'm dividing by 0. So the best way to factor, in my opinion, when it's a trinomial is to use x method. So let me kind of clear the screen here. So if I used x method, I would be saying what are factors of a times c that add up to the b value. So 2 times negative 2 is negative 4, and 3 goes in the bottom. What are factors of negative 4 that add up to 3? Well, 4 times 1 give me a value of 4, positive 4. To get positive 3, I'd have to have 4 minus 1. Did 4 times negative 1 give me negative 4? Yes, they do. So this would factor, you take your a term, you split it. So it'd be 2x plus 4 times 2x minus 1. When I say split it, I'm talking about this power here. I split the power. So I have 2x plus 4, 2x minus 1. Now I have to reduce one of these, because right now 2x times 2x would give me 4x squared. So as I look, this is the one that will reduce. 2 can divide into both of these. So this means this numerator is actually x plus 2. That's from right here. You reduce by 2. The second factor does not simplify at all, so it stays 2x minus 1. All this is over x plus 2. Notice how these two factors are the same. So what I can do is cancel these two out, and I find out that this is a removable because I removed it from the equation. So I have removable when x equals negative 2. Again, it's negative 2 because you'd have to solve this for x plus 2 equals 0, and you would get that x equals negative 2. So this would be a removable discontinuity only when x equals negative 2. Now we could graph this just to check. So when I go over here to my graph, to do piecewise, just press the button next to 9 here. Piecewise, you can go to either of these two. Since there's only 2 equations, I'll choose this one. And my first equation was a fraction. It was 2x squared plus 3x. Oops. Let's try this again. 2x squared plus 3x minus 2 all over x plus 2. And my other equation was negative x squared plus 2. This was when x was greater than or equal to 1. And this is when x was less than 1. And when I see the graph, you can notice that there's not a jump there at 1. They do meet perfectly. But as I search the graph, I don't see any breaks. But if I hit Control T, I'll see that at negative 2, there is a break. And so this is undefined, just like we said.